day before I came by.
All of it?
Yeah.
Okay, so these are the problems from 1-3 that we're going to talk about today. Are all of these pertaining to this one graph? Yes, they are. Okay, so number 14. Here's the graph that we're looking at. And the question on 14 is this. At what values of x is f continuous? Okay, so there's a couple ways that we can answer this. First of all, I could do each little individual section, use interval notation with unions between them. So, for example, I would say from -1 to 0, union, 0 to 1, union, 1 to 2, union, 2 to 3. Oops. There we go. So that's one way of saying where it is continuous. And notice that the only bracket I have is at -1 because all of these other places where I have a break, there are open circles. So that's one way. Or you could say continuous on the interval -1 to 3, except where x equals 0, 1, and 2.
So why wouldn't 3 be there as well because it's an open circle?
Here, because I use parentheses here. So if I did a bracket there, then I would include 3 here. But because of the parentheses, I'm already excluding 3. Okay, so either way, pick which one makes more sense to you and just stick with that. Okay, 15 says, what value should be assigned to f of 2 to make this continuous? Okay, so if we look back at the graph, basically it's saying what ordered pair would fill in this hole and make it continuous at 2. So what would the ordered pair need to be? 2, 0. So the question is, what value should be assigned to f of 2? 0. And then I think the next question is similar. 16 says, what new value should be assigned to f of 1 to make it continuous at 1? So instead of having the point 1, 1, I need the point 1, 2. So the value assigned to f of 1 should be 2. You can just say f of 1 equals 2.
You just put y equals 2.
That's fine. Mm-hmm. The ordered pair is fine. Mm-hmm. Something to let me know that when x is 1, y should be 2. And then the next one we had a question on was 18. Is it possible to extend this function to be continuous at x equals 3? If so, what value should the extended function have there? Okay, so is it possible to make it continuous at 3? Yes, we could just fill in the hole with f of 3 equals 0. It doesn't matter that the function doesn't exist to the right of 3. That's okay. So, yeah, f of 3 should be 0. Okay, any other questions on that? Cammie? Hang on one second, Abby.
On 9, can you graph it and explain why we don't care about this other line?
Okay. Abby,
Because I could be graphing it wrong.
Abby, what was your question?
I just wanted to see the 1 through 9, just like the book, make sure I got it right.
Oh, okay. All right, so let's look at 9 in more detail first. So the question is, or directions are, find the points of discontinuity and then identify each type. Okay, so e to a power, like e to the x, is that exponential function. It's continuous, but I can't let x be 0 in this function because it's in the denominator of a fraction. So I know that there should be some kind of a break. So let's see what this thing looks like. E raised to the 1 over x. Okay, So at 0 is where we have the break because I can't let 0 be in that denominator. So this side kind of looks like a hyperbola. This side almost looks like a backwards square root or something. So are these two coming together? Like, is there a hole there? There's a vertical asymptote, isn't there? Okay, so what kind of discontinuity do we call it when there's a vertical asymptote? Infinite discontinuity. Okay, so my question would be, or my answer would be, x equals 0 is a point of discontinuity, and we have jump discontinuity there.
That's what I put, but then the book says it's only infinite, not jump.
I mean infinite, my bad. I meant to say infinite. That's what we call with a vertical asymptote. Anytime you have a vertical asymptote, it's infinite. Was I saying jump a minute ago?
Yeah.
My bad.
Like the one to the right is infinite, but I don't see on the other line is.
Okay, so how would you distinguish? Is that kind of the question?
That one keeps going with the other line, like it just stops right there. So
Okay, if one of them appears to be approaching a vertical asymptote, though, we'll call it infinite, even if it's just one side, because clearly that looks like it's a vertical asymptote, right? So how could I tell for sure? I could set my table to start at 0, and let's go by like 0.01. And then I'm going to look to the right. See how it's just getting bigger and bigger? Not really, is it? Oh, yes it is. Good grief. E to the 43. That's easy to miss. So it's 2.7 times 10 to the 43. That's huge. So that right there is your indication that that is shooting up towards a vertical asymptote right there. Okay? So as long as one side looks like it's approaching that asymptote, we'll call it infinite. It would be jump if this looked like, I don't know, something like, I'm just going to, and then we had like a parabola or a line or something like that. Yeah, then I would call that jump. But if I see this line and something is approaching it any direction, like those four things, then that indicates a vertical asymptote. Okay, so the answer to number 1 is what we wanted. What was it? 1 through 9 odd. Okay. Answer to 1 is that x equals -2. We have infinite discontinuity. It's another vertical asymptote on that one. Number 3, it's continuous, so there's no point of discontinuity. Number 5, I don't know where that answer went. Here it is. All points in the domain that are less than -3/2. Let's look at that one in a second. Number 7 was jump discontinuity, and the discontinuity occurs at x equals 0. Let's look at number 5. That one's worth looking at. Okay, so if I had the graph y equals square root of x, hopefully we all know that it looks like that. Okay, so what if under the square root I just had x plus 3? What would that do to this graph? It would be up if plus 3 was outside. To the left 3. Left 3. And so the reason I know is because what would make that 0 is -3. So -3 comma 0 has to be an ordered pair, so it would shift at left 3. Okay, so now what does the 2 do? To figure out what I want to do is just set this equal to 0. I want to see what makes that be 0. 2x is -3. X is -3/2 or -1.5. That is the new 0. -3/2 comma 0. Because I made that equal 0, right? So now this graph comes back here at -1.5, but basically looks the same. So it's shifted left 1.5 or 1.5. Okay, so the question is, where is it discontinuous? It's not really. Like, it doesn't exist over here, but it's not discontinuous. So I think the best way to answer this is to just say it is continuous for x greater than or equal to negative 3/2. Or you could say continuous on the interval negative 3/2 to infinity.
You might just put continuous.
Hmm?
If you put continuous.
Yeah, I mean, it is a continuous graph. It's just that it doesn't exist back here, and that's indicating.
So you have to, like, explain it like that? Or can you just
I think that would be the best way, but if I just said, is this continuous, then I would say, yes, it is. And now that really the directions said find the points of discontinuity, and there really are none. It said
just put
all points in the domain less than this are discontinuous, but they're not really discontinuous, they're non-existent. You know, I don't know, I kind of have a beef with the textbook answer on that one. I think it would be best to just state there's no discontinuity. It's continuous for everything to the right and including negative 1.5. Any questions on that? Okay. All right, so what we're going to do today is continue working on continuity. If you look on your agenda, we are going to add to those problems that we just looked at. We're going to add these to those. I have a test prep packet that has multiple choice questions pertaining to the stuff that we've talked about so far. And there is one free response on AP Classroom. So we're going to work on these 3 things today. I think you should finish at least 2 out of the 3, and then if you have 1 to finish up tonight, then that will be your homework. If you finish all of them, then you have no homework. Okay? We have 1 more lesson to cover tomorrow. It's a pretty short chapter. Then we'll work on the review Friday, and your test will be on Monday. Okay? All right, so I'll stop the video and hand out